Oh, eighth grade math students, Mr. Lawrence here, and we are going to be doing some story problems, the type of which that tend to bother some kids, but they're really pretty simple things. And later on I'm going to go off on a tangent of probably about a gap in learning that many of you have. Not all of you, but some of you do. Again, I'm trying to close your gaps in your learning so that you can be prepared for high school, for algebra, because if you know how to do this stuff, then your time in algebra will be so much better off. All right. Okay, it says your family orders food from your favorite restaurant. The food costs $32. Your parent tips 20%. What was the cost of the meal including the tip? Wow. So we have to have the $32 involved, but then we have to add the 20%. Oop, not 2%, 20%, Mr. Lawrence. Read more carefully. All right, 20% of the bill. Well, how do we get 20% of a number? Okay, because if we add those together, we can't add them right now, but if we knew what 20% of the bill was, we could add them together. Well, let's see here. Getting percentages is pretty easy. Let's say I had this number here, 45. Okay, that's 100% of it. Okay, 10% of 45, if you don't know, is $4.50. Yeah, all I did was divide by 10. Remember we were doing scientific notation, dividing by 10? How do I turn 100 into 10? Well, 100 divided by 10 is 10. So to turn 100 into 10%, I had to divide it by 10, which means I had to do it over here because 45 equals the 100% mark. So I had to divide by 10 here, which moves the decimal point one place to the left. Now watch this. I can also figure out 5% real easily. Okay. How did I turn 10 into 5? Well, you could say I divided by 2, right? Well, if I divide by 2 over there on the right, I have to divide by 2. What's half of $4.50? Think about it. $4.50. If we're going to share it with somebody, you're going to give them $2.25. Right? Yeah, so 5% is $2.25. Now, if I want 1% of the number, 1%, I'm going to use this. But I'm not going to divide by 10. I'm going to divide by 100, or 10 squared, like we did in scientific notation. Well, that's going to cause the decimal point to move 2 places. So 1% of, sorry, my mouse is going all over the place, of 45 is 45 cents. Yeah, $45, 1%. So now I can use the 10, the 5, and the 1 to build any percentage I want. Watch. Okay, let's say I wanted to figure out, oh, hold on a second there. Something just finished and it popped up for me. Okay, let's say I want to figure out 7%. Well, to get 7, I'm going to need a 5%, and then I'm going to need 2 1%. All right, well, 5% was $2.25. 1% is 45 cents, and 1% is 45 cents. Now, I'm a vertical kind of guy when it comes to adding. I can do it this way. I would much rather do it vertically, though. So I am going to change the way the problem looks because I like to be in charge of the problem. I don't want the problem to be in charge of me. 225, and then a 45. And then a 45. Oops, not a 40, a 45. Sorry about that. That looks kind of yucky. Let me rewrite it. Okay. So 45. All right. So we're going to get a 5. Going to carry the 1. Let's see, that's 8, 10. That's going to be 11. Going to carry the 1. And we're going to get 315. What I'm telling you is that 7% of 45 equals $3.15. Yeah, it's pretty easy. Percentages are pretty easy. I could do it to build any percentage I want. I just have to decide how many 10s, how many 5s, and how many 1s. To do 7%, I didn't need any 10s. 0 tens, 1 5, and 2 1s. If I wanted, say, 16%, well then I'd need a 10%, I need a 5%, and I need a 1%. And I would add those three together. So that would be what? 450, 225, and 45. And when I add those together, let's see, I'm going to get 9, 11. I had to carry, right? Yeah, so that's 12. And then carry. So I'm telling you that 16% of $45 is $7.20. Okay, so let's get back to the problems we're doing. Hold on, my pen is causing me trouble. All right, so I need 20% of 32. Well, 20% of 32. Well, if 100% is 32, 10% would be $3.20, right? $3.20. All I did was move the decimal point, tack the 0 on at the end. 20% is twice that amount. So that would be $6.40. So to get the total cost of the bill, I'll take my $32 and I'll add $6.40 for the tip. And I'm up to $38.40. Yeah, pretty easy stuff. Okay. Kind of a current problem here. Some employees that make $20 per hour were given a choice of either being laid off or taking a 15% pay cut until the current pandemic is over. If the employee takes the pay cut, which means their pay rate is reduced, did you hear the subtraction in there? What will their hourly rate be? All right, so let's see here. So I know that 100% is $20, right? Okay, 10% of that would be 2. 5% would be 1, right? So I'm going to take the 100% and I'm going to subtract the 15%, leaving me with 85%. Well, the 100% is $20. The 15 can be broken up into 10 and 5, so I'm going to subtract 2 plus 1, and that should leave me with $17 per hour they are making. All right, one last type of problem I want to do. I know a lot of you look at this and you run and hide under the covers. You think, oh my gosh, this is so hard, give me a calculator, I don't know what to do, I don't know how to enter. Just stop. It's easy stuff. Let's go off on a tangent for a second about fractions. Okay, can you tell me what 6x plus 2x is? I hope you're saying it's 8x. You've had me 3/4 of the year. You should know that that's 8x. And similarly, 7x minus 3x should be 4x, right? Ooh, that's kind of weird. A hybrid number there. Should be 4x. All I'm doing is counting how many x's I have, combining like terms. I had 7 whatever they are, 7 xylophones, $7, and I gave 3 away. I'm left with 4 x's. Okay? Well, by the way, this one here does not equal x. That doesn't make any sense. Because if you had $10 and you gave away $10, you wouldn't have dollar left. 10x minus 10x is 0. If you're saying, why isn't it 0x? Technically it is, but what's 0 times x? 0. So the simplest answer is plain old 0. Okay? Now in number 4, you can't do this problem. 6x minus 3y cannot be done because they are not like terms. No, they are not. Now, why the heck am I talking about this when I'm getting ready to go off on a tangent about fractions? Because I think about these really differently, ladies and gentlemen. See this problem, 2/7 plus 3/7? I think of this as 2/7, just like this is 2x's. This is 2/7. This is 3/7, just like 3x's. 7th is the label. They are like terms because they're both 7ths. How many 7ths do I have? Well, I have 2 here and 3 here, so therefore I have 5/7. Okay. Similarly, here I have 4 elevenths plus one more 11th. I must have 5 elevenths. Okay. Now, when you get to a problem like this, like these two, you're thinking, oh, I can't do them. Well, and you're partially right. These are ninths and these are halves. You can't combine the unlike terms. However, since there are no variables, you can change the denominators so that they match. You need the least common multiple of 2 and 9, the smallest number they both go into evenly. Well, that would be 18. How many 18ths is this? Well, I'd have to multiply the 9 by 2 to get 18. Well, I'd have to multiply the 5 by 2. And so that's 10 18ths. 5 9ths and 10 18ths have the same value. To turn the 2 into 18, I have to multiply by 9, which means I have to do that to the numerator. And so this is going to be 9 18ths. And when I add these together, I'm going to get 19 18ths. Yeah, that's exactly what it means. If you want to go mixed number, you can, but you don't have to. Same thing here. I can't subtract because they're not like terms, but if I find the least common multiple of the denominators of 5 and 3, the smallest number they both go into, 15. Okay, well, I could multiply by 3 and by 3, and that would give me 12 15ths. And then here I'd have to multiply by 5 and 5. Why am I multiplying by different amounts? Because I'm trying to turn this denominator into the least common multiple. I'm trying to turn that denominator into the least common multiple. Okay, so over here I'll have 5 15ths. So 12 minus 5 is 7, and I'm counting 15ths. And there you go. All right, so let's jump back up to this problem here. Okay. The first thing I'm going to do is I'm going to go improper fraction. So I'm going to multiply 4 times 5 and then add 3. So I'm going to get 23 fourths. 4 times 5 is 20, plus 3, 23 fourths. My improper fraction. Yeah, people say you never use improper fractions. They were incorrect. We won't hold it against them, but they are wrong. Okay, so now I have 15 plus 1 is 16 fifths. Problem is, they're not like terms. I need a least common multiple. What's the smallest number that both 4 and 5 go into? Well, if you don't know how to get it, count by 5 until you say number 4 goes into. 5, 10, 15, 20. Stop! Did you hear it? 20. 4 goes into 20, right? So my least common multiple is 20. So I'm going to multiply by 4 in both the numerator and denominator. I'm going to multiply by 5 in both the numerator and denominator. And so let me see here, 23 times 5, 15, carry the 1. Looks like it's going to be 115 twentieths. And that'll be minus, let's see, 32, 64 twentieths. So 115 minus 64, looks like it's going to be 51. So my answer is going to be 51 twentieths. Now I have to divide that by 2. Well, that's the same as multiplying it by 1/2. So I'm going to get 51 40ths. Okay, if you want to go improper fraction, that's a great idea for this problem, since these, if you want to go mixed number, because these were mixed numbers, right? So 40 is going to go into 51 once. There's going to be 11 left over, and I'm dividing by 40, and there is your answer. 5 3/4 minus 3 1/5 divided by 2 is going to be 1 11/40. All right, that's it for the video. If you haven't seen the spreadsheet, well, I don't know what to call it. It's not really a spreadsheet, but the closures document. Here we go, Wednesday. You just have the video you just watched and then one Moby Max assignment. All right, that's it for the video. Mr. Lawrence signing off. Have a good day, everybody.